right, guys, only a few lessons left in the year, so let's get right to it. We've talked about already the volume of a prism, which is the area of the base shape times the height of the object, and the bases are the two parallel congruent sides that determine how the shape looks. Today we're going to talk about pyramids and cones. Now, a cone is a pyramid that has a circular base. We just call it a cone, it has one of those special names. To help us understand where the formula comes from for the volume of any pyramid, and more specifically the volume of a cone to start with, we are going to jump to another video while you're watching my video that's going to demonstrate why the volume of a cylinder is divided by 3 in order to get the volume of a cone. So what you're seeing now is a cylinder and a cone that have the same height and the same diameter and same radius for the base. What you're seeing is that the cone can be filled exactly 3 times in order to fill up the cylinder. So the volume of the cylinder is 1/3 the volume, the volume of the cone is 1/3 the volume of the cylinder. This also works for pyramids that do not have circular bases. So in this video, what you see is the prism and the pyramid both have the same height, and they both have the same shape and area for the base. In this case, it's a square instead of a circle. But what you're seeing is that it takes 3 of the pyramids to fill in the one prism. And this is where the volume formula for pyramids comes from. So the volumes of pyramids and cones, instead of area of the base times the height, it's 1/3 the area of the base times the height. All right, so we just do the same kind of formula. Capital B means area of the base. If it is a cone, then our base shape being a circle uses pi r squared in place of the area of the base, because that's how you find the area of a circle, pi r squared. So our first example, volume is 1/3 pi r squared h, because our base is a circle, 1/3 area of the base times the height. Our radius here is 21, and our height is 42. You go to your calculator, leave it in terms of pi, boom, you have your answer. If you think you're good with it, then go ahead and practice the problem. If you want to watch some more examples, keep watching, because you know how fun this is. Okay, here's another example. This time we're given the diameter, not the radius. So we take the diameter of 10 inches, divide it by 2 to get a radius of 5 inches. Take our formula, 1/3 pi r squared h, radius of 5, height of 12. Punch the numbers and round to the nearest hundredth. Hundredth, remember, 2 decimal places. Example number 3. The volume is given as 48 pi. The height is given as 81. We're going to find the diameter. So we're going to take our volume formula, 1/3 pi r squared h, plug in what we know, solve for what we're looking for. So since we know that the volume is 48 pi, we put that in for the v. We know the height is 81, we put that in for the h. I like to multiply times 3 to get rid of any fractions first. Then I can divide by 81 pi on both sides. Pi's will cancel out. So our radius squared is 144 over 81. Square root that, and we get our radius. Times 2, we get our diameter. Example 4. A full ice cream cone from Brewster's has been licked until the cone is just full of ice cream, nothing over the top. The density of a full cone is 5 grams per cubic centimeters. If the cone has a height of 15 centimeters and a diameter of 10 centimeters, then find the weight of the cone when it is full of. So what do we know? Well, we have a cone, diameter of 10 centimeters, height of 15. So using our formula, knowing that since the diameter is 10, our radius is 5, we can figure out that our volume is 125 pi. Now, it gives us the density of the full cone, so we are going to use that to figure out how much the ice cream actually weighs, and our units are grams. So 1,963.4954 grams. It's a good chunk of ice cream. Now, if your shape is not a circle, then your object is not a cone, but it is still a pyramid, where we still have to find the area of the base shape, and then divide it by 3, multiply times the height. The order that you do that, times the height first, then divide by 3, it doesn't matter. It's all multiplication. Commutative property of multiplication says you can do it in any order you want. So if we have a square base, that means the area of the base shape is side times side, side squared. In this case, 12 times 12. The height of the pyramid is 6. So you go to your calculator, push the buttons, and we get our volume. So now we got a couple practice problems. Do them on your own. Pause, do it, check out the answer, whatever you want to do, or just keep watching and we'll finish this off pretty soon. A cone fits inside a cylinder so that their bases are the same and their heights are the same. Calculate the volume that is inside the cylinder but outside of the cone and give an exact answer. Now, since a cone is 1/3 of the cylinder, then the space in between the cone and the cylinder is 2/3 of the cylinder. So there's two options here. We can find the volume of the cylinder, find the volume of the cone, and then subtract them, or just do 2/3 of the cylinder and go to our calculator and get our answer all at once. Options. Life's all about options. Okay, a right circular cone, that means that the apex is straight up from the center of the circle. The very tip of the cone is straight up from the center of the circle. A right circular cone has a base with a radius of 7, and a slant height on the cone's surface is radical 130. Now the slant height means the length of the slanted side of the cone. So it's basically the length of the outer edge. Now that length of the outer edge creates a hypotenuse with the height of the cone and the radius as the legs. So the slant height would be the hypotenuse. The height and the radius would be the legs of the right triangle. So the first thing we need to do is find our height using our Pythagorean theorem. A squared plus b squared equals c squared. When we square the radical 130, we get 130. Subtract 49 from both sides. Square root a is equal to 9. That gives us our height. So then we can go to our volume. Area of the base shape, pi r squared, times our height of 9, and round to the nearest hundredth. All right, almost done. Calculate the volume of a triangular pyramid. A triangular pyramid means it's got a triangle base and all triangular sides. That's also called a tetrahedron. But because our base shape is a triangle, our general volume formula, 1/3 base times height. We'll add in the 1/3. Turns into 1/3 1/2 BH H. Now this can get a little confusing because the two H's there, but there's two heights. One of the heights is the height of the triangular base along the bottom of the drawing. The other height is the height of the pyramid, which was 17. And it doesn't really matter which one you put in where, but the area of the base shape, the capital B, is the area of the triangle, 1/2 BH. So we do 1/3 of 14 times 8 divided by 2. That gives us the area of the triangular base, and then times the height of the pyramid of 17. And then we go to our calculator, push the buttons, and boom, bam, done. And number 4. A pyramid has an equilateral triangle for the base where each edge measures 12 centimeters in length. The volume of the pyramid is 935.31 cubic centimeters. Find the height. So this goes back to the area of a equilateral triangle. Area of an equilateral triangle would be the area of our base. I like to use 1/2 AB sine C because it's a very easy calculation. I can plug the numbers in right away. We know the sine of 60 is radical 3 over 2 because that's something that you had memorized. And then we can get the exact area of the base as 36 radical 3. Now that we know the exact area of the base, we can plug that in to our volume formula, plug in the volume that was given, multiply both sides times 3, divide by 36 radical 3, and round our answer 45 centimeters. All right, friends. Miss you guys. Hope you're doing well. That was only 10 minutes, and we did all the practice. So take care, and talk to you soon.